The ingredients for this cake are as follows. As usual, our programs are divided in 3 sections. The modules, or libraries that other people has written for us so that we don't have to. The definitions of data, and finally the code. In the module section, we have the pygame library and the math library. Math is going to be useful when we need to use assign functions. Those are the only 2 libraries we will have for now. In the data definition section, we start with the hyperparameter res, which as defined previously represents the dimensions of each of the tiles. Dimensions. Dimensions is a tuple, represented as a number of columns and a number of rows in this 2-dimensional grid. In this case, it is only 12 columns and only 1 single row. We're going to simplify this for now. In the next tutorial, we'll see how to expand it at a 2-dimensional grid and also use the y-coordinate to input as an input to the function. The screen is a tuple as well, but represents the values multiplied by the resolution of the number of columns and the number of rows. Display is a variable that represents the screen in the game. It is created by calling the display sublibrary and the setMode method, receiving as an input the screen. The first data definition is the tile. The tile is a compound data type of type class. It represents the basic unit of information in this system. This tile receives in the constructor the number of the column and the number of the row relative to the grid. Those values are later registered here as attributes in the system using self. And the values in x and y are calculated as the multiplication between c and res and r and res for the coordinate x and y respectively. Next, we need to create a rectangle, or in this case a square, by using the pygame.rect class that receives a position in x and a position in y that encodes the top left corner of that square. Res tells the program how far this top left corner should go to the right and how far it should go down in order to create a square. Self.color starts as a default value of black. The helper function draw of this tile takes charge of drawing a rectangle in the surface known as display with a particular color and using the information that came from cell.rect. We do this by using the method rect, this time in lower cases, from the draw sublibrary. A tile row is a list, a compound data type. And we populate this tile row procedurally. For every single integer c that goes from 0 to the value given in the number of columns in dimensions at index 0, right? Not including that number, because we start counting at 0. We create a new tile, passing the value of that column. However, the value in y is fixed. It is frozen at a constant value 0. Once we expand the logic in this algorithm to 2-dimensional grids, this value will also be updated procedurally. In line 34, we append the tile that we just created inside of the tile row. The data definition tile row is a compound data type. This compound data type is of type list, and the best way to go through every single item inside of a list is with a for loop. In our template, we go through every single tile. Tile is the name of the loop variable because that is the name of the variables that belong to the data definition tile. And for each of those tiles in the tile row, we do something to that object called tile. So these 3 dots will be replaced later for any function that we need to implement. Now that the data definitions are in place, let's start coding. When working with Python, the first thing we will always do is to create a draw and an update function. The draw function is in charge of rendering pixels, whereas the update function is in charge of applying the changes to the objects that are shown in the screen. These 2 functions are going to be called forever using a while loop. The first thing we will do is to change the background color. We call the name of the surface display and we use fill to change the color. Let's use a very bright color. If the tiles were created and placed properly, we shouldn't see any green in the background. I'm gonna add 3 dots here. Just for now, we're gonna get back to that point, and then I'm gonna finish this draw function by calling pygame.display.flip. What flip does is a handshake. Python doesn't have the ability to work asynchronously, so we use a different programming language, and this is just communicating with that language to tell it that it's time to update the screen. So if I run the program right now, I'm gonna have a green background. This window cannot be moved, however. As soon as I try, I get an error and the program stops responding. I need to close it. The reason why this is happening is because our window is not interactive. To turn it into an interactive window, we need to go through every single event in the update function, telling the program that we are listening and accepting inputs. For every event in the list of events in pygame that we can access using the get method, we're going to ask if the event is of type quit. If the answer is yes, then we quit the game using the quit method. This time I'm gonna be able to move the window around and close it whenever I want. I can also click in the window and nothing breaks. Let's render, let's draw those tiles. To do so, I go to the template for the tile row and I paste it in line 44. I fix the indentations, get rid of the comments, and now I can replace these 3 dots for the name of the function that will allow me to draw the tiles. However, this function is not located somewhere else and is not a global function that I have created somewhere else. It is a method in the tile itself. So we add the dot and we call draw. We run this again, and this time everything is black. No green can be seen. It means it works. Let's focus on the algorithm. The general idea is to visit every single tile in the system. For that, I copy the template. These 3 dots will be replaced for the name of a helper function. We're going to take the position in X of the tile, and we are going to pass it through a function, and the output of that function will represent the color of that tile. So it seems that we need to use the position in X and the color of the tile. So here we're going to simply call this function map from function. Now, I want my program to have the ability to receive any functions, any function that takes a tile and applies the transformation to the x-axis based on their own specific rules. So I'm going to create a higher order function that is going to take as the first argument this tile, but also is going to receive the name of a function. I'm just going to call it fn0. I'm going to have fn1, fn2, and so on. Whatever comes out of this function is going to be an integer. It's going to go between 0 and 255. So I just need to change the color of the tile to that variable C. However, colors in pygame usually are represented as the saturation in 3 different channels, red, green, and blue. So I'm just going to say C, C, and C. We need to create a map from fn and a function fn0. Let's start with the function fn0. fn0 will be the modulo. It will receive or consume the tile, and it's going to take the variable x of that tile and apply the modulo operation by 255, which is the maximum value that this channel can take. And we are simply going to return the value. That's it. Let's create the helper function. Map from function. This function is going to receive a tile and another function. The reason why we can pass functions to other functions as parameters and returns is because functions are what is known as first-class citizens. Now that we have this, it's time to create a value. The value is the calculation of the function when it receives the tile's position in X. We are simply going to return the integer version of that value because we need integers to represent colors, and our program is done. Let's run this program and let's see what happens. Oops, seems that we have an issue here. The error says integer object has no attribute x, tile.x modulo 255. This is in line 54, so let me just check line 54 real quick. And this value right here, it should not be a compound object to type tile, it should be a float value. And what it should return is also a float. Okay, so these comments right here are just for me and other programmers, so that we specify the signature of this function, what enters and what exits that function. Now I know that x should be a float, which was the cause of the error just now. Okay, so here we're just gonna take x and we apply the modulo. We run it once more and there it is. So we have the values with 0 saturation where the number of the pixel where the tile is in the x-axis is 0. And as we move towards the right, eventually we reach values that are closer and closer to 255. But once we get over 255, everything gets restarted. Therefore, we get these beautiful gradients right here. Let's create another function. Let's call this one fn1. The signature is the same. It should always be the same. And here, what we are going to return is the math sign function of x plus 1 that we talked about in the explanation of the algorithm. And that is going to take us to the positive values. We multiply it by 127 and we return it. Let's call it here. Instead of calling fn0, we're going to call it fn1. And there it is. Now, maybe it's not very impressive. Let's be honest, it's just a bunch of squares with a couple of grayish color. When we are dealing with sine waves, however, the most important thing I want you to notice is how the values go back and forth, right? So we start with pale values, go towards black values, and then we apply the reverse process. We start with dark values and start going with pale values. So that is one of the attributes of wave-like functions. So let's increase the resolution. Let's make our squares a little smaller. Let's make it actually of size 4. Let's have 250 of these guys and let's see what happens. So let's run it. And that is really hard to see. I'm going to cheat. I'm going to go here and I'm going to change the resolution, vertical resolution, that is 100 times, to make it bigger by a factor of 100. I need to apply it here, right? Because that is the dimensions in the y-axis of the screen. And if I run the program right now, I'm gonna end up with a screen that is taller, but is filled mostly with green pixels. Because the values of the squares, because the height of each of the square is still of the original resolution. So I need to stretch vertically also in the height of each of the tiles. And that happens here. I multiply res by a factor of 100. I run the program once more, and this time I have a nice stripe pattern representing the sine wave function.